Hello 3BLM, you've missed your lesson again, which makes me very sad. I've forgotten and I've booked all this kit. I'm not going to book it again, I'm just going to show it to you and make you watch the video for homework. This is a piece of string. Now, if I pluck the piece of string, a wave travels this way down the piece of string, strikes the end where it's hanging over this pulley, and it reflects back again. And when that happens, the wave which is going this way and the wave which is going this way start to interact with each other and do something called interfere, which is what we're going to learn about today. If I send repeated waves from this end using this vibration generator, you can see the piece of string doesn't react much at very low frequencies, but as I increase the frequency, there's a certain frequency at which it reacts really quite strongly. And this is something called a standing wave being set up, where there are positions on the piece of string where the wave being sent this way by the vibration generator is interacting with the wave which is reflecting off the far end of the string in a constructive manner, which means both of the waves, when they reach this point at the same time, are pushing the piece of string in the same direction. And so we get a point of maximum oscillation in the middle called an antinode, and points where there's no oscillation at all at either end. This is happening at about 230 hertz, 230 vibrations per second. If I double the frequency up to about 460, we can get a second standing wave. There we are. And now we've got a point in the middle, which is almost entirely stationary, where the wave coming this way and the wave coming this way are interfering with each other, in this case destructively. And so there is no vibration at that point, even though there are two waves crossing over and passing through the string at that point. There is an antinode here where there's lots of vibration, and there's an antinode here where there's lots of vibration. So this is the second harmonic of this system. If I increase the frequency again to 3 times the original frequency, we can get another one. There we go. Now I've got an antinode here, a node 1/3 of the way along, an antinode here, a node here, and an antinode here. This is another stable standing wave. This is another harmonic of this string system, and I can get a higher frequency again, which has got 4 nodes in it, if I tune it right. It's around here. Then if you can see that, that's not bad. There's a node here where the string is stationary. There's a node here where the string is stationary. There's a node here where the string is stationary. So that means, if this was a string on, say, an instrument or something like that, whilst the basic frequency the string plays would be this one, which is it's called the fundamental mode. That's the fundamental standing wave that can be formed. That would be the actual note, if this was, say, a guitar string, that the guitar string would play. There would also be present within the sound that the guitar string made all of these other harmonics, which is much smaller amplitude, but they'd be adding to the overall shape of the sound wave made by that string. So you get the harmonic series. This one is double the frequency of the fundamental mode, so it's 1 octave higher, and then this one is 3 times the frequency of the fundamental mode, and so that is it's actually a 5th higher than the previous note, and then the next one up is a 4th higher, and then the next one is a major 3rd up, and the next one is a minor 3rd up. So this is standing waves on a piece of string, which is a demonstration I'm not going to show you again, because we're not going to get the kit out again.